We're going to take a look here at IXL Geometry U12, which is Inscribed Quadrilaterals Part 2. This one's a little bit more involved than Part 1, and you'll see why. If we take a look at this first circle here, we see we've got quadrilateral A, B, C, D inscribed in the circle. And we're going to go ahead and start labeling some things that we know about this quadrilateral here. We know that D is 103 degrees. So that means across from angle D is angle B, and those two are supplementary. That would be 77 degrees right there for angle B. Okay? So 77 plus 103, that'll add together to give us 180 degrees. So this means since angle 77, this is an angle degree of 77 degrees here. So this whole arc that it creates here from A, B, C is going to be twice that. If we multiply 77 by 2, we end up with 154. So this whole arc here, from C to D to A, is 154 degrees. We see that 81 degrees is eaten up with CD. So then what's left for AD? Well, let's check that out. This would need to be 154 minus 81. That's going to be whatever's left over. If you wanted to set up an equation, you could say 81 degrees plus the measure of arc AD is equal to 154, or you could just do 154 minus 81, and that would leave you with 73 degrees. I'm going to erase all this. I'm going to turn off draw and zoom. I'm going to try this here, 73 degrees, submit it, and you are in good shape. Let's turn this on again for another diagram. In this one, we've got some similar setup. We're looking here for arc BC. So we're looking for this arc all the way around here. So we're going to have to know something about an angle somewhere in this quadrilateral. Here's what we know so far. We know angle 115 is over here. We know we could figure out angle C. So what's going to be supplementary with 115? It would be 65 degrees. So angle C is going to be 65 degrees. That is because 65 plus 115 is going to give us 90 degrees. Or sorry, 180 degrees. Now that we have that, how does that help us? Well, we could figure out that this whole arc here, and I'm going to change color to red, this arc DAB all the way around here should be twice what 65 degrees is. So if we come in here and we dot this DC all the way up to CB, what we see is that this angle, this inscribed angle, is going to be related to this arc length here. And this arc length is going to be twice whatever this angle is. So 65 times 2 is 130 degrees. And there's a reason that I'm doing this, okay? So when I look at, and there are other ways to work this problem. When I look at CD, we get 89 degrees. We know this whole thing over here is 130 degrees, and the whole circle is going to be 360 degrees. So what you could do is say 360 degrees is the whole arc length for our entire circle. And then I'm going to subtract out the 130, and I'm also going to subtract the 89. Forgive my scratchy writing with the mouse. If we type this into our calculators, 360 minus 130 minus 89 degrees, that's going to give us 141 degrees. So if we take a look here at 141 degrees, that should be our answer. I'm going to show you another way to look at this problem, though, okay? This might be a little bit more direct, but the idea here is that when you're given a diagram, there's not always a single way to solve a problem. A lot of times you can attack it in a lot of different ways, but let's make sure that we still end up with an answer of 141 degrees. So I'm going to turn back on my pen, and let's take a look here. So DAB is inscribed, and it's 115 degrees, yeah? So if we double that, that's going to be 230 degrees on this entire arc from this angle. So that would be this entire arc out here. So 115 times 2 is 230 degrees. So this entire arc from BCD is going to be 230. If we want to go in here and we want to figure out what BC is, we would just have to subtract out the 89 that we know. So 230 minus 89 is going to give us 141. So two different ways to work that problem. Both are nice, and both will give you the same answer. So when you're going along through these problems, I want you to maintain this idea that if I keep working and I keep using the rules that I've learned, I can solve this. There's not a single thing that you need to do as soon as you start to get it right, but keep chugging away at it, and you'll find some stuff out. It's trying to get us to figure out AD on this one. So since I'm looking for AD, I see here that I've got DC as another measure of an arc, and it's 98 degrees. So if it looks like if I could find B, if I could find measure of angle B, B is going to make this arc out here from AD to NDC. So what I'm going to do is I'm going to try and figure out what measure of angle B is first. We know that D and B are supplementary. So if we do 180 minus 84, it's going to leave us with 96 degrees for angle B. So that means arc length from ADC would be twice of 96. If you take your calculator, do 96 times 2, you're going to be left with 192 degrees. Now 192 is our entire arc length from A to D to C. We're going to come back and we're going to subtract out 98 degrees from that, and we're left with 94 degrees. So 192, and then we're going to subtract 96, and that's going to leave us with 94 degrees. I'm going to clear this out. I'm going to type this in. It's going to tell me that I'm awesome or marvelous or great job. And guys, I appreciate you watching this video. If there are other questions that you have, feel free to comment on this video. If you want to learn more IXL, please subscribe.